Hi everybody, this is Dr. Fouladian. We're going to start chapter 4, that is integumentary system. So here you see the whole system of the integumentary. You see that the organs and components that are included is the main part is skin, that we call it cutaneous membrane. We talked about that before. The skin has two parts, epidermis and dermis. Then we have the hair follicles, includes the hair and some glands that we have around it, sebaceous gland, we're going to talk about them. We have some sweat glands, nails, sensory receptors, and subcutaneous layer. These are all part of the integumentary system, and you have the function of each one of them here that we're going to talk about each one and we explain about the function of each one. So as you see here again, the integumentary system is composed of skin. So skin by itself, it names integument. As I explained here in this lower part, you see that in biology, integument is the natural covering of an organism or an organ, such as its skin, husk, shell, or ring. It derives from the integument, which means a covering in Latin, and that's the source of that one. I wanted to emphasize on this one because there is a confusion between the meaning of the integument and the parts that are included in different sources. So I wanted to make it clear that integument by itself means skin, but integumentary system is beyond the skin only. So integumentary system beside the skin covers the subcutaneous layer that is located under the skin. You remember we called the skin as cutaneous membrane. So subcutaneous is under cutaneous, under the skin. It is not part of the skin, subcutaneous layer, but it is part of the integumentary system. The other things that are part of the integumentary system, that's hair, nails, exocrine glands, the glands that pour their secretions out through a duct, that include the sweat glands, sebaceous gland, mammary glands, and ceruminous glands. We're going to talk about each one of these ones. And finally, we have some sensory receptors. Those are at the beginning of the sensory neurons that take the sense from all around the skin, the somatic senses like touch, pressure, vibration, and other things, and take it toward the central nervous system. So, as the skin is the most visible organ of the body, and that's a very big organ of the body actually too. So among all the organs, the skin covers the most area, and it's actually the biggest organ of the body by itself. And besides that, not only the surface area, a clinician can tell a lot about the overall health of the body by examining the skin. For example, the color of the skin. If the color of the skin is so pale, we can tell that not much of blood is coming to the skin. So it might be simply the blood pressure is so low that the body is contracting the blood vessels of the skin so that the blood go to the more vital organs of the body, like brain, heart. So it might be just a compensation of the body in a state that we call it a shock or near shock state due to the deep hypotension, very low blood pressure. So just by looking at the skin and you see somebody suddenly become pale, you can say that, oh, it's going to shock, right? Or many other things, like when the when the content of the hemoglobin of the blood goes low, the skin may become like blue, or the ones that we call it as a cyanotic, right? So that's just example. Or when the skin becomes so red, we can say that too much blood is coming due to the too much temperature or other reasons. So there are many things. We just can look at the skin, or when the skin becomes yellow, that's the one that we call it jaundice, and it may have so many causes behind that itself, right? So this is just the color of the skin. There are many other things of the skin that can tell you about what's going on beneath that and in the overall health of many systems of the body. So the functions of the integumentary system as a system. So physical protections from the trauma, chemicals, and entry of the pathogens. That's because of the skin. Control skin permeability and prevents water loss. Otherwise, we had to water every minute instead of every hour, right? Regulation of the body temperature. We will talk about that we have so much blood vessels in the skin, and part of regulation of the body temperature is through those blood vessels that we have in the skin. Excretion of the products such as sweat, that some of the waste of the body can get out of the body through sweat. Synthesis of the products, like they synthesize and store lipids and vitamin D3. As you know, vitamin D3 is it has so many acts. It kind of somehow can be considered as a hormone because it works on many parts of the body, and also lipids, that when you have lipid available under the skin, whenever you need energy, you can use them as a source of energy. Sensation, like touch, pressure, pain, temperature, all of these ones, they have sensory receptors inside of the skin. It starts from there to take the sensation toward the brain. Immune defense help coordinate immune responses to pathogens and cancers. So those are all the functions of the whole integumentary system and the parts that we have in the integumentary system. Structurally, we have cutaneous membrane that we know that as skin. The skin by itself has two parts, epidermis and dermis. Then under the skin we have hypodermis. Also we have some accessory structures in integumentary system, including hair and hair follicles. We will talk about them. Nails, exocrine gland, and sensory receptors. So here you're looking at the drawing of the part of the skin and under the skin. As you see here, you have this part, epidermis, part of the skin. The next part of the skin, deep to the epidermis, is dermis. And then, so these two makes the skin, epidermis and dermis. Then under the skin, we have hypodermis. Hypo means under, right? Under the dermis. So as you see, dermis is the deep part of the skin. And above dermis, we have epidermis. So, as you see here, epidermis is the superficial part of the skin that is the epithelium. And if you remember, that's the stratified squamous epithelium, and the type of that is keratinized stratified squamous epithelium. Then we have the dermis, deep to the epidermis, that is underlying connective tissue under the epithelium. Later we're going to talk about this dermis, that by itself, this connective tissue is composed of two types of the connective tissue and makes two layers of the connective tissue in the dermis we're going to talk about. Then hypodermis, that is deep to the dermis, and also known as the subcutaneous layer, because it's under the cutaneous layer, or the superficial fascia, as we already talked about that before when we were talking about the connective tissue and the different types of the fascia. So you see that the hypodermis has three main: hypodermis, subcutaneous layer, and superficial fascia. And this is not normally considered to be part of the integumentary skin, but it is part of the integumentary system, as I explained. And pay attention that if it is written in your book otherwise, I will accept this one as it is said here. Hypodermis is not part of the skin, but that is correct. Hypodermis is not part of the skin, but it is part of the integumentary system that has been written here. So, talking about the cutaneous membrane skin, we said that it has epidermis and dermis. Now let's go over the general function of each one of these. Epidermis, that is located above, and it is the stratified squamous epithelium that is keratinized, as you see the layer of the keratin here. This function is protects dermis from the trauma and chemicals, control skin permeability, decides that what can pass through to get inside or not get inside or outside, and prevents water loss. That's a big help to preserve the water inside of the body. Prevents entry of the pathogens, synthesizes vitamin D3, and sensory receptors detect touch, pressure, pain, and temperature. So you see that these are all the functions of the epidermis. What about the dermis? Dermis has two layers, as I mentioned earlier. Now here you see the name of the layer. The top layer that is closer to the epidermis is called papillary layer. That is a thinner layer compared to the deeper layer that is called the reticular layer. Now, papillary layer of the dermis has the function of the nourishing and supporting of the epidermis. If you remember, epidermis is or in general, let's talk about the epithelial tissue or epithelium is a avascular tissue. You remember that one? So when there is no vessel in the epithelium and here epidermis, so it should get its nourishment somehow, oxygen and also the nutrition and all the things that is needed to get into the tissue and to get rid of all the waste and the carbon dioxide to get back into the blood vessels so that it gets out of the area, right? So epidermis doesn't have blood vessels inside it. So somehow it should get all the needs, right? And here you see that it gets all these needs regarding the nourishing and all those ones from the first layer of the connective tissue that is located right under the epidermis. And later you will see that we have blood vessels in this layer, and the nutrition and the oxygen comes from those parts, go into the epidermis, and epidermis gets back the carbon dioxide and all the waste into these blood vessels that we have in the papillary layer. So that's main functions, nourishing and support of the epidermis. What about reticular layer? Reticular layer is a deeper layer in the dermis, and its function is restrict the spread of the pathogens penetrating epidermis from deep to the epidermis, stores lipids, it has some lipids, and attaches skin to the deeper tissues, and sensory receptors detect touch, pressure, pain, vibration, and temperature are located here. So as you see, it's almost the same as the epidermis, just the vibration is more and as it is deeper. And blood vessels assist in thermoregulation. Thermoregulation means regulation of the temperature, right? So that's a big part that we have as a one of the main functions of the skins, because we have big blood vessels here in this layer, deep into this layer between the reticular layer and actually the subcutaneous layer. We have big vessels that whenever the body needs to get rid of some heat, so those vessels may get dilated so that some more blood comes over there and they lose heat through the skins, or whenever the whole body needs to preserve the temperature, so those blood vessels may get contract so that less blood comes into those areas, right? So they have a big role in the thermal regulation. So besides the skin and the hypodermis, we have accessory structures as we talked about them before, and at the end of the chapter we're going to go review them. So those accessory structures, regarding their general functions, we have hair follicles that produce hairs that protect scalp. So hair follicles are the layers that are covering around the hair. Hair is the one that is coming out of the skin and sometimes falls off. So that's hair. Hair follicle is the tissue that we have inside of the skin, we have around the hair. So those hair follicles protect the hairs, and hair protects the scalp. Produce hairs that provide delicate touch sensations on general body surface, right? We're going to talk about those ones more. And exocrine glands that assist in the thermoregulation, for example, sweat glands, expellic waste, again sweat gland, duplicate epidermis, so like for example sebaceous glands, and the other ones. We're going to talk more about these ones in more detail. And finally, nails that protect and support tips of fingers and toes, right? So getting back to the skin as the first organ of the integumentary system, pay attention that each one of these parts are considered one organ, like hair is in one organ or hair follicle. Each of these glands, sweat glands, sebaceous glands, skin by itself, or subcutaneous layer, each one of these ones is an organ, as we had it at the first slide. So in this picture again, you see the same things that you saw, simplified type of that. Epidermis here, that is the epithelium, papillary, and then we have dermis. The whole part is dermis, that it has two layers. This top part is papillary layer, and this lower part is reticular layer. And you see all these blood vessels that we have between these two. Then you see here all the accessory structures, hair. Then you see the pores of the sweat gland. You see some sensory receptors like tactile corpuscle, that is for the light touch sensation. Then you see the sebaceous glands that go next to the hair. You have this muscle that attach to the hair, that we call it erectochylean muscle. And then we have the duct of the sweat gland here, and other corpuscle, lamellar corpuscle, that is other sensory receptors, sweat gland, nerve fiber, that we have so many nerve fiber around here, and finally another sets of the bigger vessels that you have here between the dermis and hypodermis. So let's talk about the epidermis first, as the top layer of the skin. In general, we have four types of the cells in the epidermis. And always remember that epidermis is the stratified squamous epithelium that we have on the top layer of the skin, and the type of that is keratinized stratified squamous epithelium. Now let's see what type of cells do we have here. We have four types of the cell, that the most common are called keratinocytes. They make about 90% of all the cells that we have in the epidermis. The function is produce a tough protein that called keratin. That's why we call them keratinocyte. Remember, cyte means cells. That aids in the protective function of the skin, produces antibiotics and detoxifying enzymes. That's another function of the keratinocytes, and produce secretion to aid in waterproofing of the skin. So these are all functions of the keratinocyte that makes about 90% of all the cells in this. The other one, the second common, are the melanocytes. Melanocytes are the cells that are producing melanin, and melanin is the pigmentation that makes the color of the skin. And you just know that the melanin is the one. We have generally two types of the melanin that have different type of pigmentation, that might be more brown black or more yellow red, right? And also the amount of the melanin that is produced in each cell makes the different tones of the skin in different people. So that was the second most common type of the cell. As you see, these two types of the cell together makes about 98% of the cells in the epithelium. The other two types that make generally 2% of the cells together, one type is called Merkel cells, that they are sensory cells. We're going to see them. And the last one is called Langerhans cells, or dendritic cells, that those are wandering macrophages, that they are searching for pathogens and toxins to get rid of them, right? So this is part of the immune system of the skin. That's how the skin takes part in the immunity, prevents the pathogens, and it just guards the border between the inside of the body and outside of the body through the Langerhans cells. As you're noticing from here, over each organs of the body, you may have all those macrophages, that they are phagocytic cells, but we name them differently so that we know that when we talk about them, whenever you hear Langerhans cells, you know that this is a macrophage, a phagocytic cell that is located in the skin. Right? And the other name for them is dendritic cells. Now here you see the picture of each one of those cells. First one is keratinocytes, that they produce keratin inside of them. You look at the shape of a cell, you see due to the presence of those tough keratin that they're pushing the membrane of the skin out, the cells, not the skin, the membrane, they're pushing the membrane of the cells out. You see that the membrane of the cell is like the spiky, like that one, and that is the shape that you recognize keratinocytes for that. And then we have melanocytes, that they have lots of melanin pigmentation inside of these granules. Then you have tactile epithelial cells, or Merkel cells. So the other name for the Merkel cell is tactile epithelial cell. Tactile means related to touch, and they are located in the epithelial part of the skin. Therefore, we call it tactile epithelial cells. They are also called Merkel cells. As you look at here, these cells, tactile epithelial cells, are close to a sensory neuron. This is part of a neuron that is called tactile disc. This is the beginning of a neuron, a sensory neuron. Whenever the fine touch pushes these cells, tactile cell, and it hits the tactile disc here, it produces an action potential here that is transferred through the whole sensory neuron to get to the central nervous system, and that's the way that these cells are transferring the sense of touch, light touch. And finally, the last type of the cells are intraepidermal macrophages. That is another name for the Langerhans cells, as these macrophages are located inside of the epidermis, intraepidermal macrophages. So, layers of the epidermis. Epidermis that is stratified squamous epithelium. You remember that stratified squamous has several layers, 2 or more layers. In the skin, this stratified epithelium usually has 30-40 layers of the squamous cells, right? All these layers have different areas with different characteristics, 4 to 5 layers, and we call each one as a stratum. So the deepest layer means away from the surface is called stratum basal, or the other name for that is stratum germinativum. Stratum germinativum because they are germinating the other cells, they are producing, generating new cells and send them up toward the surface of the skin. In other words, they are kind of stem cells that are able to divide and produce new cells. And those are in the deepest layer of the epidermis. Then after that we have stratum spinosum. We call them spinosum because of the shape. This layer is mostly all by the most of the cells here are keratinocytes, and as I showed you the picture of the keratinocytes, they are spiky, like the spines that are coming out of the cell. Due to that, we call them spinosum. Then after that we have stratum granulosum. In this layer, we have some more granules that makes them, they make a pigmentation and they make the color over there. You see that as a different color, a thin layer of the color cell that they, because of their granule that they have, we call it a stratum granulosum. Then we have stratum lucidum. Lucid means transparent, without color. And this is a layer that is seen as a white or empty space, but it's only in some kind of the skins that we're going to talk about that. And the final top layer, the most superficial layer, is called stratum corneum. So let's go and see these ones actually over the skin. So as you see here, this is the surface of the skin toward the air, and this is deep part of the skin. And this is the whole part up to here is just epidermis here. That is composed of stratified squamous epithelium. The deepest layer is stratum basalis. These are those basal cells, as you see, like for example, here is showing a division, mitotic divisions here. And we have it here. Then after that, we have a stratum spinosum, that they have some spike around each cells here. And this almost is the thickest layer and the most number of the keratinocytes you have here. Then you have the granules here that you see the coloration, the darker color, the stratum granulosum. Then we have a stratum lucidum that the cells are transparent, and finally we have the dead keratinocytes that makes the stratum corneum that might be thin or much thicker depending on the part of the body that we are talking about its skin. So these are these 5 stratum of the skin. Now let's go talk about each layer. And here you see that tactile epithelial cell or merkel cell that is attached to the tactile disc continues with the sensory neuron. Now let's talk about each one of these a little bit more. The stratum basale consists of a single layer of the basal cells that I showed you. Pay attention that basal cells are still keratinocytes, but they're stem cells. Keratinocytes mean that they still have the ability to divide and do mitosis. Cells in this area are undergoing active reproduction, and location of they have melanocytes. Some melanocytes can be seen among all these basal cells that they produce pigment of melanin. Lack of melanin results in albinism. Albinism are the condition that the people they do not have melanin at all. For example, their eyebrow, their eyelashes, even the pigmentation of the iris in the eye may lack all those ones, and due to that one they look more white. Pigments transfer to the keratinocytes, pigment of the melanin, and protect nucleus of keratinocytes from ultraviolet radiation. When I get to the picture, I will show you how these melanocytes are protecting the skin from the UV light. And the skin surface that lack hair contains specialized cells known as Merkel cells in the stratum basal. So pay attention that the Merkel cells are seen in the hairless skins, because not all skins all over the body have the hair. Like for example, tip of your fingers, they do not have any hair, right? So some parts of the body that they do not have hair, we have Merkel cell over them in the stratum basal. So pay attention that in stratum basal, besides the basal cells that we have melanocytes and nectar cells. I call them M and M, right? So there are two and those are delicious, right? In the stratum basal, melanocytes and Merkel cell, two M's that you have here. Then in the, let me see if I have the picture here, or I'll just get back to the previous picture and show you here. In the next pictures, I will show you the melanocytes and how they're protecting the, oh here, it's here. So here you see that you have a melanocyte. You see that melanocyte has some extension that goes between the other cells and sometimes above them, like an umbrella when cover the keratinocytes over there. And you see the pigmentations also get into the extensions too, like here that you see, right? So these ones, these melanins, this pigmentation of the melanins, protecting the cells. And what exactly they are protecting? They're protecting the nucleus of the cell. The nuclei that you have in these keratinocytes here, they contain chromosomes. And chromosomes are always, they are especially near the basal cells. These cells still may be under continuing, like as you see here, in continuation of the mitosis, right? So when the cell is dividing, the DNA is replicating, dividing, producing another one. It is active, and always when a cell is active and some parts of the structure is active, is doing more actions, the chance of something going wrong is more compared to some parts that is fixed, no change, nothing happens over there, right? So whenever you have a division in a cells, DNA is replicating, there is a chance that you have something wrong during the division. And the UV light that comes from the outside, from the surface of the skin and goes over all these ones and all the nuclei of these cells and all the chromosomes and DNA of all these cells, increase the chances of something going wrong during the divisions, right? And these melanin pigmentation that they are covering like an umbrella over those cells prevent the damage of the UV light over the DNA of all these keratinocytes. So that's the job of the melanocytes or the autonomic stratum base. Now in the stratum spinosum that you saw that make a big part of the skin. They are mostly keratinocytes that are bound together by desmosome. Desmosome, you remember that they are cell junction that keep the two neighbor cells tightly attached to each other, and that's the one that we need in the skin. We do not want when you rub the skin, oops, one part of that goes away, right? You need them to be tightly attached to each other. The other things, we have some Langerhans cells among the keratinocytes that are most common in the superficial portion of the stratum spinosum because they want to be closer to the skin as a pathogen comes from the outside. Just grab it at the beginning, at the border in the Mexican line, right? Keratinocytes move from deep to superficial part of epidermis and become filled with keratin, the near external surface of the skin, eventually worn away. That's the process that we call it keratinization. So keratinocytes start getting divided at the basal cells, and that's the part that makes the skin to grow and renew, right? It starts from the stratum basal. So from those ones, these keratinocytes come into the stratum spinosum, and they are moving upward toward the surface. As they move upward, they produce more keratin. They fill with more keratin, fill more, until eventually the only thing that remains is only keratin. So at the end, they lose all the organelles. Like when they get to the stratum lucidum, all the organelles have gone. You just have a shadow of the cells filled with keratin. So at that point, the cells have died when they get to the stratum lucidum. And eventually, they make only a layer of the keratin, and by washing, they worn away that you may see them as a household like dust part of there and everything just go away of the surface of the earth, right? So that's the job of the keratinocytes that we have in the stratum spinosum and also the Langerhans cells that we have. Then the next layer is the stratum granulosum, granular layer, that keratinocytes here secrete waterproofing material that they are inside of those granules, and keratinocytes begin to flatten and die by apoptosis. All those internal organelles they just go away, and the cell starts to get ready to die. And keratinocytes produce lots of keratin and keratohyalin. So that's important in these cells that we have here with excess synthesis produces calluses. When you have lots of these material over the part of the skin that is under continuous contact with other things like the friction continuously, like if your job is just, for example, to hammering, for example, those parts of the skin that are in contact with hammer continuously for years, they make the calluses, and that's because of this. And finally, stratum lucidum, that they are clear, flat, dead keratinocytes. So pay attention, still up to the stratum granulosum, there are some parts of the cells still are alive. At the stratum lucidum, they're totally dead. And only in thick skin can you find the stratum lucidum. Right, that thick skin are the part of the skin that like we find in the fingertips, palms of the hands, and soles of the feet, right? So in those areas that you have a thick skin, you have a stratum lucidum. In other words, in the thick skin, you have 5 layers of the epidermis. On the other parts that are thin skin, you have only 4 layers of the epidermis because we do not have stratum lucidum in thin skin. And as we said, lucidum means transparent, and because of their color, we call them lucid. And stratum corneum, the most superficial layer that consists of interlocking dehydrated dead cells. So these cells are obviously dead too, and they are full of keratin and continuously shedding of the surface of the body. Pay attention, the difference between the thick and thin skin, besides of having or not having the stratum lucidum, comes with the thickness of the stratum corneum too. Thin skin generally have a thinner stratum corneum, and thick skin have a thicker stratum corneum. So here you see the epidermis under the microscope here, that you see that from the superficial layer you have a stratum corneum, then you have a stratum lucidum that here have been colored in this color, then you see this darker layer of the stratum granulosum, how you differentiate that under the microscopes or models, and then you have the stratum spinosum, and finally you have one single cuboidal shaped cells that is stratum basal layer here, and under that the dermis starts here. So this is the border of the epidermis and dermis, and as you see, they make some bridges toward the epidermis, make some bridges deep into the dermis, comes up, makes another ridge, goes down and goes up. So that's the way that these two is like this part that the epidermis goes and lock into the dermis to make more connection, more surface for the attachment here. And here, just as have it here, you see the corpuscle of touch in the papilla of the dermis. So in other picture here, you see the epidermis from here all the way to up here. You see that the thick part of that is just stratum corneum. You see a transparent part, stratum lucidum. Then you see that stratum granulosum. You see stratum spinosum, and finally you see stratum basal here, and under that you have the dermis. So here you have all the characteristics of each part as we discussed. Again, emphasizing the difference between the thick and thin skins. So thick skin can be found in the palms and soles, as we said before, and also the fingertips, made of 5 layers of the cells, and they do not have hair. So those thick skin are generally hairless. Thin skin found on the rest of the body, made of 4 layers of the cells because they do not have a stratum lucidum, and they have hair with some exceptions, right? So pay attention that it is not that all the thick skins have hair, all the thick skin do not have hair, or all the thin skins have hair. Later, when we get to the hair, we talk about exactly which parts of the body have hair, which parts of the body do not have hair. But just know that generally, thick skin do not have hair. But for the thin skin, we may have some exception because some parts of thin skin do not have hair. So here in you looking at the model that is showing all the skin and subcutaneous, and here this part you have a thin skin, in this part you have a thick skin, just put next to each other so that you can see the differences. So besides that, in thick skin we have a stratum lucidum. Also the stratum corneum is much thicker compared to the thin skin that in this model you can compare very easily. And generally you see that thick skin do not have hair and thin skin generally have hair, but there are some exceptions to that. So we said that so looking at the same model that picture that you saw before, this is a thick skin. As you see, that's a very thick stratum cornisome compared to thin skin that has a very thin stratum cornisome. And this thin skin that does not have a stratum lucidum, and this one has a stratum lucidum. So that's a comparison between the thick skin and thin skin that has been taken from hair border of the epidermis and dermis. So this picture, this part is good to see all these ridges that are between the epidermis and dermis. So these projections of the epidermis toward the dermis is called epidermal ridge. That is one epidermal ridge, next epidermal ridge, next epidermal ridge, right? Then the same way part of the dermis that are going to interlock with these ones are projecting up, right? We call those ones from the dermis as papilla, dermal papilla. That's why the first part of the dermis is called papillary layer. So these papilla are getting into the epidermal ridge, and this makes a connection between them. Just as we have this picture here, I want to tell you that whenever you have a severe rub over, continuous severe long rub over a surface, like for example, you've been walking for 5 hours non-stop on a shoe that is not comfortable and one part of your skin is rubbing against one part of the shoe that is there has lots of friction between these two at that specific point, right? Like for example on the under your big toe, right? After 5 hours, you see that one part of your skin is painful, and you see that actually the skin has got separated, right? And you see some fluid under there. What do you call it? Blister, right? And that is actually the separation of these two layers from each other. So blister is the fluid that is gathered in this area and makes these two layers get separated. The epidermis gets separated from the dermis in this area. That is how it would look like if the epidermis and all those epidermal ridges get disconnected from the dermal papilla and you have a space between them. It would be blister. That is the one that sometimes happening, like for example in some skin diseases or some burns and many other. So as we said, that is regarding the dermal ridges. Stratum germinativum forms the epidermal ridges, right? Stratum germinatum is a stratum basal, that's the lowest layer of the epidermis, right? Ridges extend into the dermis and forms the dermal papilla in the dermis. Just pushing into those ones we call dermal papilla. Pay attention, we usually do not call them dermal ridge. But your book has done that. Just know that what does it mean. Those are usually called dermal papilla. If epidermal ridge reveal on the surface of thick skin such as fingertips, they create ridges we call fingerprints. So let's look at them. How those epidermal ridges can take part in the fingerprints, ridges that we call fingerprints. So here you're looking at the skin that we have in most surface of the body, like for example on the dorsum of your hand, right? So as you see, this is a flat skin. There is no ridge that you see the same as the one that you see over your fingertips, right? Compare this one and still you see that you have all those epidermal ridges and dermal papilla here. Now, this is just the same picture that we had, and you see here, you see the surface of the skin is flat, like most skins that you have over the body. This picture has been taken from the part that you have, like as the fingertips here, that you have some ridges over the surface of the skin. When you look here, you have the epidermal ridges here, but also these ridges have been projected over the surface of the skin too. You do not have a flat surface of the skin here. The surface of the skin also are following those epidermal ridges that they have deep too. That's the one that is making all those ridges that we have in their fingertips. The same is here. So pay attention. What we are detecting are these surface ones. If we have these projections on the surface, we have these ridges. But pay attention that those epidermal ridges are deep. We do not see them, and we may have a complete flat surface over the top that we have in most of the skins of the body, that there is no fingerprint in it. I just wanted to draw your attention how you have this one, and those are not exactly epidermal ridges, as we have epidermal ridges all over the body, but when they project toward the surface too, then they make these pictures of these curves that we have over the surface. And as we have a specific pattern for every single person, we can use these ones as their fingerprints. Pay attention that on the top of each one of these ridges, we have the pores for the sweat glands. And those are the ones when we push the tip of the finger over any surface, all the sweats at the top of all these ridges remain on the surface, and that's the one later we can recognize the pattern because the sweat has remained on that surface. So, a few words regarding the skin color. We pay attention that the skin color has come not just by melanin. Many things are affecting the skin color. It might be due to the dermal blood supply. You remember we said that the amount of the blood inside the skin may cause different colors of the skin. Reductions in blood flow results in a pale color. Sustained reduction of blood flow results in cyanosis, actually reduction of the hemoglobin. Saturations results in cyanosis. Thickness of the stratum corneum also makes a difference in the color of the skin. Various concentrations of the keratin and melanin, they cause different color of the skin, and these two are under genetic control, that how much melanocytes and how much melanin. So regarding those pigmentation, keratin and melatonin, keratin derived from carrots, corn, and squash, and convert to vitamin A. So the body needs that. Vitamin A is needed for synthesis of visual pigments in the photoreceptors of the eyes. And melanin, but too much of that actually may cause that your skin color can change. And melanin produced and stores in melanosomes within melanocytes, right? Melanosomes are those granules that they have melanin inside them, and creates natural skin color and tan, and protects the skin against UV radiation, as we discussed. Oh, this is the picture that I was searching for. It is here. So as I explained to you, this is a melanocytes in the basal layer stratum basale and how it goes over the keratinocytes that are still under activity, and it may extend here on the top of them and protects all the nuclei from the UV light that's coming from the outside. So melanocyte activity, exposure to the UV light, we discussed about that, increases the rate of melanin. When we have exposure to the UV light, increases the rate of melanin formation, and that is actually a protective mechanism of the body to protect all those cells from the UV light, and that causes the tanning process to begin, because more melanin, more tanning, more color of the skin. And repeated exposure to UV light can result in a long-term epidermal and dermal damage, because at one point those melanocytes cannot compete to a long and lasting UV light exposure, and results in abnormal connective tissue structure that may cause the premature wrinkling. Instead of at the age of 80, you might get it at the age of 40, can result in epidermal skin cancers. So that is the most important part, that we have to protect our body by other means too against UV light. Don't just rely over the melanocytes, because they have some ability, and also don't stay in the UV light too long, more than 20 minutes. So here you see a normal nevus or a mole over the surface of the skin. Sometimes we call it benign nevus. That is just extra cells that have some pigmentation, but they're totally benign. They just stay there and stay there for years, and they do no harm, right? That is just may bother that it is there. Sometimes some people may like it even, but when they start changing, when they start spreading, become irregular, change the colors, irregularity, and all those ones, that's a warning signs that they are become malignant, cancerous. And like one example here is malignant melanoma that comes from the melanocytes, right? And that is why it's important. UV light can cause cancer from many different cancer type of the cancer. I think I have a slide to show you. It's not just melanin that becomes cancerous, also melanocyte malignant melanoma is the most dangerous and most progressive and so on. So that's just wanted to emphasize that how protection from the UV light is important to prevent the cancers and some other diseases of the skin. So the other job of the skin, as we discussed, is formation of the vitamin D. That is a good part of the UV light that is doing. UV light converts a cholesterol-related precursor of the vitamin D to convert it to the vitamin D. Vitamin D is called cholecalciferol. Now, vitamin D3 undergoes changes in the liver and kidney, so it starts in the skin, then it has to go to do some more processing in the liver, and after that into the kidney, and then finally becomes the active vitamin D that can do its job. So vitamin D finally converts to the active form of the vitamin D. That one is called calcitriol. So that was another things about the jobs of the skin, and those are done inside of the epidermis. So that was all about the epithelial part of the skin, that we call it epidermis. Now below the epidermis we have dermis. So dermis consists of two layers: papillary layer, that is the superficial dermis, and reticular layer, that is the deep dermis. As you can see here again, this is the papillary layer. and this is the reticular layer. Okay, so let's finish this part and we put the rest for the next video. For the papillary layer consists of the loose connective tissue and is actually areolar connective tissue. They have dermal papilla as we discussed, they have capillaries, and those are the ones that they are nourishing due to the diffusion of the material. The material diffuse into the epidermis and nourish the epidermis. And some axons of the neurons are located in this layer. Papillary layer provides physical attachment to the epidermis, right? The reticular layer that consists of interwoven network of the dense irregular connective tissue. That's the part that under the microscope you saw as the broken glass. And then they have hair follicles, sweat glands, and sebaceous glands too. So we have some changes in the skin right here, wrinkle, stretch mark, and the tension line. So let's talk about these ones in the next video. So have a great time. We're continuing this conversation in the part 2 of the integumentary system.